Welcome back to Tales of Chemistry. Today, we are discussing about Standard 10 ICSE Chemistry Metallurgy, the second, third, and fourth step involved in metallurgy. Step 1 was already discussed in previous episode. Step 2 in metallurgy is the conversion of concentrated ore, dressed ore or concentrated ore is converted to its oxide. There are two methods for conversion of the oxide to conversion of ore to its oxide. The two methods are roasting and calcination. Now, roasting is recommended for sulfide ores. Calcination is recommended for carbonate ores. Now, let us see what is this roasting and calcination. Roasting is the process of heating the concentrated ore in presence of excess of air. All right. So the key words here are heating of the concentrated ore in excess of air to a high temperature, or else you can write strong heating of the concentrated ore in presence of excess of air is called roasting. This underlined words are the key words here. During the strong heating in presence of excess of air or oxygen, the ore combines with oxygen to form its oxide. In other words, when your ore is having no oxygen, then you will have to supply oxygen and heat it strongly. That is roasting. I've given two examples here. One is zinc sulfide or zinc blend is strongly heated in presence of oxygen to form ZnO and SO2. Sulfur dioxide is a gas which will be removed easily, which can be removed easily. Second equation is with FeS2 iron pyrides, plenty of oxygen. It gives you Fe2O3 and 8SO2, sulfur dioxide again. So here I've written generally sulfide ores are roasted. Second process which we need to study, which is for carbonate ore, is calcination. The difference between the ores that are used in roasting and calcination is, in roasting, the ore is not having any oxygen, whereas calcination is done when the ore is having oxygen, like the ZnCO3. Calcination is the process of heating the concentrated ore in a limited supply of air or in the absence of air. So one of the key points is limited supply of air or absence of air. Second key point is at a temperature below the melting point. It's compulsory to write below the melting point of the ore. That is calcination. Again, I have given two examples here, ZnCO3 and FeCO3. Zinc carbonate and ferrous carbonate, both on calcination, gives you ZnOCO2 as well as FeO and CO2. CO2 is a gas which can be removed easily. Now, there can be a question, why do we have to perform either roasting or calcination in metallurgy? So the answer is here. Concentrated ores are converted to their oxides because oxides are easy to reduce. So your answer is, it is easy to reduce an oxide to its metal. Moving on, the third step in metallurgy is a reduction of the oxide to its metal. And this process of reduction is done based on the position of the metal in the activity series. So if you remember, activity series that which we have studied earlier, contains potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, etc. It goes on like that. The metals which are on the top, that is potassium to aluminum, okay, those metals lose their electron easily, which means they are easily oxidized. Loss of electron is oxidation. You can oxidize those metals easily. That again means a reduction of the metallic oxide to metal will be difficult. So the oxides of those metal which occupy the top position, potassium to aluminum, potassium oxide, sodium oxide, calcium oxide, magnesium oxide, aluminum oxide, all of these are reduced by electrolysis, by passing electricity through the molten oxide. Then those elements which occupy the center, the middle part of the activity series, zinc to copper, zinc oxide, iron oxide, etc. They are reduced using suitable reducing agents. What are examples for reducing agent? Carbon is a reducing agent. Carbon monoxide is a reducing agent. Even hydrogen can be used. So oxides of zinc to copper are reduced using a reducing agent like hydrogen, carbon, or carbon monoxide. Finally, oxides of silver and mercury, they are reduced by strong heating, which is called thermal decomposition. That is all about step 3. Under this, the reduction of aluminum oxide to aluminum, that we will be discussing in detail. Rest, chances are very less that in the board examination they ask any question based on step 3 other than the extraction of aluminum. Last step, which is actually out of syllabus, is out of syllabus in metallurgy, is electrorefining. That is with regard to aluminum. Electrorefining of aluminum is out of syllabus, is what I meant. But electrorefining, basic information we have studied this in electrolysis chapter. That's all in this episode. Stay tuned for more videos. Thank you.